Welcome to Test Sentinel. When you first start the application, you'll be presented with this home screen that has a variety of different options and tools that you can choose from. We won't be discussing many of them in detail in this demo, as we will be focusing on the custom test creator in just a little bit. However, a very powerful tool of Test Sentinel is the CO device interface. This tool allows us to easily control any DPU or DSLAM that Test Sentinel supports in a very consistent and reproducible manner. For instance, I can connect to any of the DPUs I wish, select any port to control, and I can set or even create and load my very own profiles, or select from any of the standard profiles that come with Test Sentinel, such as the 212A profile that is used for Gfast testing. These settings are all completely generic, meaning I can create a profile once, save it, and then I can set this profile onto any of my DPUs or DSLAMs respectively. This tool handles converting the profile to the appropriate commands based on which DPU or DSLAM you are connected to. Once I have a profile set on either my DPU or DSLAM, I can then check the admin status, set the admin status, and check the training status of my line, as well as pull any measurements that the DPU or DSLAM supports. This is a demo device, so I won't have very many measurements here. The same can be done for performance counters, or even getting a full graph of the bits and gains for a particular port on a DPU or DSLAM. Similar tools exist for controlling traffic generators or controlling noise and loop simulators. Test Sentinel still comes with the original test automation engine. This test automation engine allows for automation of TR-114, ID337 issue 1 and 2, and more tests. Now, while this test automation portion of Test Sentinel is somewhat customizable, meaning you can select which profiles to use, which devices to use, and what timing to use, it does not allow the user to fully customize or modify the test script. And this is where a brand new feature of Test Sentinel comes in, called the Custom Test Creator. For this demo, I'm going to create a very simple DSL reach versus rate test to show how easy it is to create and modify a test script. I'm going to go ahead and create a new test and give it a name, my demo reach rate. And when I'm creating a test, I can choose to create it based on a certain template that is provided by Test Sentinel. I'm going to base this test off of a simple reach versus rate template, which will provide us with the basic structure of a reach rate test that we can then modify and add on to meet our needs. I'm going to go ahead and save this test, which will then bring us to the test editor. The test editor works very similarly to a drag and drop programming language, except very specialized to a certain domain. The test editor might look like there's a lot to it, but each part is actually quite simple. Since I made this test based off of a template, you will see that this template comes pre-populated with some test actions, as well as comments on every single action. This way, a new user can get to know exactly what everything is doing when they create a new test, as this demo is just going to quickly gloss over some of the key features of making a test. The user guide and documentation also provides a lot more information on how to actually use and create a test. As I mentioned, tests are created using items called actions. An action is the smallest piece of a test and are what I'm clicking on right here. An action is kind of like a single statement in a programming language. You can see that here, I am connecting to a specific DSLAM, I am then connecting to my AWG, or noise simulator, and then connecting to a loop simulator that will simulate a certain loop length. There's a very wide variety of actions available, ranging from anywhere from simple if statements and loops, all the way to very specific actions such as controlling a traffic generator and getting traffic results, or getting measurements or performance counters from a DSLAM or a DPU. You'll notice that as I click on a specific action, the settings on the right-hand side change. These settings determine what an action requires to run. For instance, when connecting to an AWG or my noise simulator, I have to select which device to connect to. Note that this device isn't actually the noise simulator I will be controlling, but rather it indicates that when a user wishes to run this test, they must select a noise generator. I'll show you that in just a few moments. Tests have three major parts to them: events, sections, and functions. Events are denoted by a green E on the tab that is currently selected. You will notice that I have the Check Setup tab selected, which shows me all actions within this event. The Check Setup event runs at the very beginning of every single test, and therefore I'm using it to connect to a DSLAM, noise simulator, and loop simulator. Similarly, there's an End test event here. This event runs at the very end of a test, or if there's an issue in a test and there's an error, this will also run. This helps us to clean up anything in our test, such as disconnecting from our devices. Next are sections. Those are marked with a red S on the tab. This template already comes with a basic reach rate section created, though of course you can make as many as you wish. A section can be chosen to be run or not to be run by the tester. So it's really useful to split your tests up into individual sections, that way you can choose what needs to be run and not be run. This section simply sets a few variables, including the DSLAM profile that we will be using, the loop lengths that we will be using, as well as the loop type. As you can see here, this test defaults to 26 AWG loop type, ranging from 0 to 5,000 feet in 1,000 foot increments. Finally, it defines a variable for noise, which is just set to -140 white noise for this demo. It then calls a function that is created by the template using these variables that will actually run the reach rate code. Functions are denoted by an orange F next to the tab. You'll notice that this section is calling the run basic reach rate function, which we will take a look at now. This function will begin with setting the appropriate DSLAM profile. In this case, it is accessing whatever parameter was passed to this function and setting that profile to the DSLAM. It then does the same for the noise simulator and sets the noise simulator profile, and then enters a for loop block that loops through every single loop length I wish to test in this reach versus rate script. All of the other actions are placed within what is called a point block. A point block is purely used for organizational purposes and makes the data that appears on the database easy to understand and be organized. So, as we iterate through this for loop and through every loop length, we set the WLS profile, or the loop simulator, to match the settings that we defined, and then we begin resetting, training, and stabilizing the ports of our DSLAM via the train lines action. Every action has a unique label associated with it. As you can see, this one is called Basic Trainer. They can be renamed to whatever the user wishes for easier test creation. This is very important because most test actions are able to produce what we call measurements, or essentially data that we can use later on in our test after an action runs. We can view the measurements of an action by clicking the View Measurements button when an action is selected. By doing this, we can see that our train lines action will provide us with some information regarding the training process, such as whether or not all of the lines trained, how long it took a certain port on the DSLAM to train up, or if there was a stability failure, for example. We can use this information later on in our test script. For example, the if-else block here, that comes after training the lines, checks to make sure that our basic trainer action had all of the ports on the DSLAM trained, and it makes sure that there was not a stability failure. If the ports on the DSLAM did train and there was no stability failure, the if statement will run. In this case, we take line measurements, which get automatically recorded to the database, just as all of the measurements of every action in the test, and then we print to the screen some useful information. This can be completely customized. In this example, we just print out the actual data rate and SNRM of the line. We can then do various things, such as setting the point status to a pass or a failure. We can also add items called section metrics, which are requirements for a section to pass. In this case, we make sure that there was no connects. Basically, we ensure that the DSLAM port trained for each loop length. Now this test will run as is, but what if we wanted to make a quick modification and get performance counters and compare them for each loop length? Well, we know that in this if statement here, we take our line measurements if the line is trained. We can do the same thing with the get performance counters action here. We'll take the get performance counters and drag that into our test. Immediately, every single performance counter recorded from the DSLAM will be recorded to the database for us automatically, and we can also view its measurements. For instance, the get performance counters action will provide us with almost any performance counter that the DSLAM or DPU supports. And again, this information is automatically recorded to the database so that we can view it once the test runs. We can do other things, such as getting the bits and gains, by simply dragging in the bits and gains action if we so wished. I'm going to go ahead and save this modified test, and we can go ahead and run it. Back on the home page, we can select the test engine and select the test that we wish to run. In this case, I'm going to load the demo reach rate file that we just created, which will open a variety of settings. Here, it will list all of the sections available within the test, in this case only one, that we will select to be run. It will then show us a bunch of variables that are in our test that we are able to optionally change if we so wish. This way, if I wanted a shorter train time, reset time, and stability time, I can change those here without going into the test creator and changing the test script every time. For example, the next tab over has our DSLAM profile that we could change here, as well as the loop lengths that we are running our test with, all without re-editing the test. Once these settings are set, we can go to the device configuration tab. This will allow us to select the actual devices that the test will be run with. Once all of these settings are through, we can go to this test status tab, enter in our tester name, and begin the test. The test will begin by running all of the actions that were in the check setup block. So that was connecting to our DSLAM, noise simulator, and loop simulator. You'll notice that once those devices are connected, we will see a live log of all of the commands being sent to the DSLAM, noise simulator, and loop simulator. There's also a status log that prints out the current progress of the test. For instance, here we can see that we just started loop length 2,000 feet, it set the WLS profile, and it's now training the lines for us. Once the lines get trained, it takes line measurements as well as our performance counters. We can see that it printed out a nice table of all the performance counters, even though all we did was add a single get performance counters action to our test. We can also see the printouts of the actual data rate and SNR that we had in the log status action. On the left, we can see what current section is running, as well as what loop length is running down here as well. There's also an action viewer that can show us what current action is running in our test, and we are able to set breakpoints and view variables as the test is running, which is very useful for debugging and creating your own tests.